Welcome back to the channel. So it's been a long time. I've been preparing and now I'm ready. So let's go. So in today's video, grade 11, I got a lesson on acid and bases, as you can see. So we'll be learning about acid and bases. So lesson objectives. I want to teach you and show you so that you can pass your September term 3 test. Currently we on August 26, 27, 27, and 2026, and soon you're gonna write term 3 test. So let me walk you through that path, and maybe you're gonna learn something from these videos. So lesson objectives, we're gonna learn how to determine the common acid and bases together with their formula. We're gonna define acid and bases in terms of Arrhenius and Lowry Bronsted theory. See, we got acids like hydrochloric acid, HCl. We got nitric acid. Hydrochloric acid that is we found in the stomach, nitric acid and sulfuric acid, also ethanoic acid or acetic acid. And we got a bases. We got ammonia. We got sodium carbonate, washing soda. We got sodium hydroxide carbonate, caustic soda. We got potassium hydroxide. What I can tell you is that if you can see hydrochloric acid and nitric acid, they are strong acid and weak acid. So I saw the trick here is that when you are looking to identify strong acid, they will start with the H in front. You see, hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4, which means they start with the H in front. So these are strong acid. But weak acid, we talk about ethanoic acid or acetic acid because it will end with OH like CH3COOH. You need to know the acid and the formula because you are going to use this a lot when you are balancing equation and doing all those things. So we got ammonia is NH3, which is a base. I think it's a strong base, this one, but you will show. I will see you in the next video. Sodium carbonate is a base, and hydrogen sodium hydrogen carbonate. You need to know how to write this formula, and potassium hydroxide KOH. So you need to know um how to write this formula. So let's continue. All acids consist of hydrogen ion. So we know that an acid will always have H plus and a hydroxide will always have OH minus, right? So far we're still together. So Arrhenius, Svante Arrhenius, like I said, he won the Nobel Prize in 1903, Nobel Peace Prize in Chemistry, because he defined acid in a simplest way that anybody can learn. Like before the Lowry Bronsted came up with their own theories, already Svante Arrhenius defined acid and a base. This is how they defined acid and a base. He said Arrhenius described acid as a substance that produces hydrogen ion in aqueous solution. Okay, this is the example. As you can see, if we add hydrochloric acid plus water in liquid, we're gonna get H3O plus aqueous plus Cl minus. Okay, so this is the first example I'll show you today. Hydrochloric acid in water increases the concentration of H3O plus ions and is therefore an acid. So that's why Arrhenius described acid as a substance that produces hydrogen H3O plus or H plus ions in aqueous solution. He also described a base as a substance that produces hydroxide ion in aqueous solution. Example, if we add sodium hydroxide with water, we're gonna get a metal, sodium, sodium. We're gonna get a metal, sodium ion and hydroxide ion because a base is a substance that produces hydroxide ion in aqueous solution. Sodium hydroxide in water increases the concentration of hydroxide ions and is therefore a base. So in the previous example we had let's say HCl in aqueous solution. Let's say HCl hydrochloric acid in aqueous solution plus H2O in liquid will give us this hydrogen. This hydrogen, let me use a different color, black. um this hydrogen will come to the water, and then we're gonna be left with Cl. And if this Cl loses this hydrogen, it's going to be okay, this hydrogen is coming to water, which means it will increase the hydrogen ions, you see. And then in aqueous, plus Cl will be alone, so it's going to be Cl minus in aqueous solution. So this is what Alhenius is saying, that an acid is the one that increases the hydrogen or H plus ion in aqueous solution, and also a base is the one that increases the OH minus ions, hydroxide ions. If we take something like sodium hydroxide plus water, we gonna get sodium metal, which is sodium ion and hydroxide ions, because um, a base is a substance that will produce these hydroxide ions in aqueous solution, hydroxide ions. So this theory of Arrhenius, right, it was not complete, because many scientists went on to do research. This is sodium hydroxide, to do research and find out about acid and base. And we got Laurie Bronsted, which who came up with different perspective on how we define acid and base. Let me show you what Laurie Bronsted did. So what Laurie Bronsted did about acid and base, these are two scientists, of course. It was a Danish chemist, Johannes Bronsted, and an English chemist, T.M. Lowry, who independently proposed new definition for acid and bases, right? An acid was defined as the proton donor, while a base is the proton acceptor, right? So the Lowry Bronsted definition does not require acid and bases to be in aqueous solution. Okay. Um, let's check this. The Bronsted-Lowry model defines acid and bases in terms of their ability to donate or accept protons. Lowry-Bronsted described an acid as a proton donor. Lowry-Bronsted described a base as a proton acceptor. Okay, so as you can see, the example here, we get hydrochloric acid plus ammonia. Then this hydrogen in front of HCl is going to ammonia, and it will give ammonia NH3. It will become NH4 plus, because it gained a proton, and the chlorine, because it is losing, it will be minus. You can see, simple. So Lauren Bronsted described an acid as a proton donor, and then it described a base as a proton acceptor. Check this out. In order to decide which substance is a proton donor and which one is a proton acceptor, we need to look at what happened to each reactant. The reaction can be broken down as follows. If you add, hydrochloric acid, and then the hydrogen will be a proton donor. So it will go through NH4, and the chlorine will be remaining with the minus. Then we got we had NH3. So now when we add another hydrogen, which is NH3 is a proton acceptor, which is a base, and then HCl is a proton donor, which is an acid. So from this reaction, it's clear that HCl is a proton donor and is therefore an acid, and NH3 is a proton acceptor and is therefore a base. Simple as that. So you need to know strong acid and bases. Strong acid is a substance that ionizes completely in water to form high concentration of hydrogen ions. Example, we got HCl, H2SO4, HNO3. Like I said, for you to remember this strong acid, they will always start with H, HCl, H2SO4, and HNO3. So, a strong acid, we got hydrochloric acid, sulfuric acid, and nitric acid. So strong base is a substance that dissociate completely in water to form high concentration of hydroxide ions. Example, sodium hydroxide, potassium hydroxide. Strong bases you will see because they will end with OH. So weak acid and bases. Weak acid is a substance that ionizes incompletely. It's just the opposite. When it comes to strong acid and weak acid, it's just the opposite. Weak acid is a substance that ionizes incompletely in water to form low concentration of H3O plus ions. This side, strong acid is a substance that ionizes completely in water to form high concentration. So the difference is that strong acid will ionize completely in water to form high concentration, but weak acid will ionize incompletely in water to form low concentration of hydroxide ions. Example, we got acetic acid, CH3, COOH, and COOH2. Weak base is a substance that dissociates incompletely in water to form low concentration of OH ions. Example, Na2CO3, sodium carbonate, ammonia, sodium hydroxide carbonate, calcium carbonate. This calcium carbonate, the one that you find, the hard cover of the eggs, a chicken eggs, was made up by calcium carbonate. And we got K2CO3, which are weak acid, weak bases. Sorry, weak bases. Now we're gonna talk about conjugate acid base pairs. Conjugate acid base pairs. You need to know what is a conjugate acid base pairs. In an acid base reaction, there are two conjugate acid base pairs. An acid that donate H plus to form its conjugate base. Conjugate acid to base pair 1. You can see conjugate acid to base pair 2. A base that accepts H plus to form its conjugate acid in the reaction of HF and H2O. We can identify the conjugate acid and base pairs. How do we identify this conjugate acid and base pairs? Let me show you between these two reactions. Between hydrogen fluoride in aqueous solution plus H2O, which is liquid, we're gonna get what? This hydrogen, of course, is coming to this side is going to be H3O plus in aqueous solution plus fluorine minus in aqueous solution. So we want to know the conjugate acid base pairs. So it's simple. You need to know which one is your proton donor. Proton donor is this one, acid 1, and this one is going to be proton acceptor, is going to be base 1, because we know water can be an ampholyte, it can act as an acid or base. And then we come here to this side, we got proton acceptor. This one is going to be acid 2, this one is going to be base 2. So when you want to know conjugate acid base, is that We know that this is the conjugate acid base pair of this one, and this one is conjugate acid base pair of this one. I didn't make a mistake, right? If I made a mistake, comment and tell me down there. But I think this is how you do it, because we want to know which one is a conjugate acid base pair, which one is a proton donor, which one is a proton acceptor. So yeah, this is how you do it. Trust me, this is how you do it. I will just stop the lesson right here. I'll continue with the lesson about acid and base, because I'm not done and I don't want to make this video too long. But what I can do is the fact that I can pause this video here so that you can go and do this activity one. You go and do this example and come up with solution. You go and create your own equation and show me the answers, then I will correct you. Write the conjugate base of the following: HBr, H2S, H2CO3. Write the conjugate acid of the following: NO2 minus, NH3OH minus. So you go and do these examples and send me the answers on my email, physicalsciences with Saint Nicholas. Just make sure you copy the email, send me the answers, write it on your somewhere where I can see on your paper, take a picture, show me and send me the answers on my email. Then I will show you the real answers. Also, I'll send back my real answers. Again, we're gonna use the email. So before I can go forward with the topic, let me pause this video here, and then I'll come up with more episode. So um write the conjugate base of the following. So how do I find out this conjugate base of Hb with what? With water. Of course, it's going to be liquid. Here it's going to be aqueous, and this is what we're gonna get. um this hydrogen is going to be this side, so it's going to be H3O plus, and we're gonna be left with Br minus. So we know that this is the acid one, this is the base one, this is the acid 2, this is the base 2. So this is the conjugate acid base pair. You see, simple. We are looking for this answer. This is the answer, Br minus. But we want to know, how did you come out? How did you get that answer? And then this is another conjugate acid base pair. Conjugate acid base pairs. And this is how you do it. Simple, elegant, and you know what I mean. So I'll continue from here. I'll come up with more questions, and I'll show you, teach you more about ampholites and etc, etc. Anyways, I'll see you in the next video.